Okay, key features. So first we need to get the equation. So let's see what points we have. -1, 8, 0, 6, -2, 6, 1, 0, -3, 0. Okay, so first difference. Second difference. Okay, so A will be half of the second difference, so -2, and C will be +6. So -2x squared plus bx plus 6, and we'll substitute in x equals 1. And then when x is 1, the output should be 0. Okay, so 1 squared is 1, times -2 is -2. B times 1 is b, plus 6 equals 0. -2 plus 6 is +4. Okay, so putting it all together, we have -2x squared minus 4x plus 6. Okay, domain, I know that for a quadratic I can go forever to the left, forever to the right, so all real numbers. Range, I can go downward forever, and then the highest y value I hit is right here at +8. And I do actually hit +8, so I use a bracket, not a parentheses. Vertex, I can see from my graph, is -1, 8. Axis of symmetry, the vertical line which goes through the vertex. Okay, so again, every point on this line, we got -1, 0, -1, 5, -1, 10. These all have an x value of -1. Okay, x-intercepts, I can see it crosses the x-axis at -3, 0, and +1, 0. Y-intercepts, it crosses the y-axis at 0, -6. 0, +6. Opens downward, right? The opening is down here. End behavior. Okay, so as x approaches infinity, as I go forever to the right, the parabola heads downward forever. So we say that approaches -infinity. And as x approaches -infinity, as we go forever to the left, f of x again goes downward forever, so approaching -infinity. Okay, intervals of increase and decrease. So where is the graph going upwards? So starting at -infinity and going all the way until x equals -1. Okay, so notice we always reference the x value where you stop, not the y value. Also notice we always use parentheses for intervals of increase and decrease. Okay, so decrease, starting at x equals -1, going on forever, I'm walking downwards. Roots, what are the x values, which have an output of 0 when x is -3 and when x is +1. Okay, and then any minima or maxima. Well, we go downward forever, so you can never have a minimum because you can always go further down. But this point right here is the highest point in its little area, so it's a relative maximum, and it's the highest point in the whole graph. Okay, finding the equation over here. Ooh. So what points do we have? This one looks halfway in between. So it's 6, 7, 7.5. Then we have 6, 0, 8, no, that's 9. this is 10 comma 2 and 11 comma 5. And this is 12 comma 9. Okay, so the kind of tricky thing is we can't really use these values in the middle because we're not counting by ones. So I could use the entire right side or the entire left side. So since I want to get closer to x equals 0, I'm actually going to go back and do the fill in the left side. So I got 6 comma 0, also 5 comma 2, 4 comma 5, and 3 comma 9. Okay, those are the only points I can see. Okay, so first difference. Okay, not a constant first difference. Repeat. Okay, so we do get a common second difference. And that means the a value is half of positive 1, so just positive a half. Okay, so now how do we get the c value? This is kind of tricky. So we need to go backwards a little bit. So let me get more room. Okay, so following the pattern, right? So going upwards, -2, -3, -4, this would have been -5. Okay, so something -5 is 9, that'd be 14. Okay, continuing the pattern, this would be -6. So something -6 equals 14, that'd be 20. And then finally, something -7 equals 20, so that'd be 27. Okay, so then my c value is 27. So I'm at f of x equals 1/2 x squared plus bx plus 27. Okay, so let me plug in f of 1. Okay, so 1/2 of 1 squared plus b times 1 plus 27 should equal, when the input is 1, the output is 20. Okay, so let's do some simplifying. 1 squared is 1, so half of that is a half. Okay, so a half plus 27 would be 27.5. And then subtract 27.5 from both sides. Okay, so 20 minus 27.5 would be negative 7.5. Okay, so put all together, we got, let me just do everything in decimals, I guess. So half x squared would be 0.5 x squared minus 7.5x, and then plus 20. Oh, excuse me, plus 27, that's the c value. Okay, domain, again, we know quadratics can go forever to the left, forever to the right, and everything in between, so negative infinity to infinity. Range, the lowest y value I hit is right here at -1, and I do hit that value, so bracket. Then I can go up forever, so approaching infinity. Vertex, I can see is 7.5 comma -1. Axis of symmetry, again, always goes through the vertex. So x equals 7.5. Okay, x-intercepts, I see 6 comma 0, it crosses the x-axis, and 9 comma 0. Y-intercepts, I calculated 0 comma 27. Okay, this one opens upward. And behavior, as x approaches infinity, as I go forever to the right, the graph goes up forever. And as x approaches negative infinity, as I go forever to the left, f of x also goes upward forever. Okay, interval of increase. So starting at x equals 7.5 and forever to the right, I'm walking upwards. And decrease, starting forever to the left until I get to x equals 7.5, I'm walking downward. Okay, roots, the x values at which the y value is 0. When x is 6, y is 0, and when x is 9, y is 0. Okay, and then I don't have a maximum because I can go upward forever, but this point, the vertex, is both a relative and absolute minimum. Okay, so to find the vertex, I could just plug in points until I find the vertex when the numbers change direction, but the better way is to use the axis of symmetry formula. Which is x equals negative b over 2a, right? So b is the coefficient of x, a is the coefficient of the x squared. Okay, so for problem 8, negative b will be negative 6, and 2a will be 2 times a half. Okay, so that's 6 over 1, so just 6. Okay, so the axis of symmetry is x equals 6, and this tells us that the vertex's x coordinate will also be 6. Okay, because the vertex always lies on the axis of symmetry. Okay, now how do we get the y coordinate? Well, we just plug it in. Okay, so the y coordinate of the vertex is negative 4. Okay, so the focus, well, I know this parabola opens upward because of the positive a half, so the focus will be above it. Okay, so how much up do I go? 1 over 4a, or again, a is 1/2. Okay, so I move up half a unit. So from the vertex, you go up half a unit. And then on the other hand, the directrix is the other direction. So from the vertex, you go down half a unit. So half a unit below negative 4 is negative 4.5. Okay, and the length of the latus rectum, that formula is 1 over a. So 1 over a is 1 divided by a half. So that's 1 over 1 times 2 over 1 is 2 over 1, or 2. Okay, so repeat that process for g of x. So in this case, a is 1/8. Okay, b is negative a half. Okay, so axis of symmetry would be negative 1/8 over, no, sorry, negative b, so negative 1/2 over 2a. Okay, so this simplifies to 1/2 over 1/4, and 1/2 divided by 1/4 equals 1/2 times 4 over 1, which is 2. Okay, so the axis of symmetry is x equals 2. So then, okay, the vertex will be 2 comma something. Now let's get the y value through substitution. Okay, so when x is 2, what is y? That's what an equation does. It tells us that. Okay, so let's see, we got 4 over 8 is a half, minus 1 plus 7 over 2. Okay, so this equals 6 over 2 or 3. Okay, so the vertex is 2 comma 3. Now I need 1 over 4a to get the vertex. Okay, so 1 over 4 times 1/8 becomes 1 over a half, which is 1 over 1 divided by a half, which is 1 over 1 times 2 over 1, which is 2. Okay, so from the vertex we go 2 units to get to the focus. And again, this is a positive a value, so I know this parabola opens upward. So from the vertex, I go up 2 units to get to the focus. I go down 2 units to get to the directrix. And then 1 over a, 1 over 1/8 becomes 1 over 1 divided by 1/8. Okay, so the latus rectum is 8 units long. Okay, lastly, problem 10. So this time a is -2 and b is -4. So axis of symmetry. Okay, so it looks like the axis of symmetry is x equals -1. Okay, so now let's get the y value of the vertex through substitution. Okay, so 1 times -2 is -2, plus 4 plus 9, so that would be 11. Okay, and now let's find 1 over 4a. Okay, so 1/8 of a unit, which in decimal form would be 0.125. Okay, so this parabola has a negative a value, so this one opens downward. So the focus is below the vertex. So subtracting 0.125 from 11, we get 10.875. The directrix, on the other hand, would now be above the vertex. So you would add to the y coordinate. Okay, and the latus rectum, absolute value of 1 over -2 would just be half a unit. Okay, and finally, sketch a quadratic function with axis of symmetry at 2, focus at 2, 3, and directrix y equals 1. Okay, so I'll draw my axis of symmetry first. Okay, focus at 2, 3, directrix at y equals 1. Okay, so I know that the vertex is always equidistant from the focus and directrix, right? So if we've got the focus at 2, 3, and the directrix is y equals 1, so including the point 2, 1, halfway between them, the vertex must be 2, 2. Okay, and then in a later unit we'll talk about how to know the width of it, but for now we'll just focus on this part.